Crewton Ramone's House of Math. Good, no, good stuff. So 2/3, you went all the way to 13, right? And 13 is 26 over 39.
Yeah.
But so can you see that basically all this is 2, right, over 3. So 2.
Yeah. Also
over,
known as 1/2.
Also known as, let's see here, 1/2 is 1/2, and 2/3 and 1/2 are not the same. Right? So think about it. Here's what we're doing. We're doing 2/3, right?
Yeah.
And then you did 4/6. And then basically, I would cheat and just get out one of these and one of these and slide them over. So that takes you all the way to 10/20, right? And then look, then I can just put them on the end here like this. Oh, look at me, I'm pro at this. So then I have 2 12s over 3 12s, which we don't even have here. We got all the way to 6. But you got all the way to 13. You actually did an extra one, right? You did 13 over 2 13s over 3 13s, right?
Yeah.
Okay, and we're just seeing. So you can see that 10/15 reduces to 2/3, right?
Yeah.
Alright, let's do the next one. Let's do another one. I'm going to cheat and do 3/4. So it should be easy. You already did your 3s. So anyway, 3/4. So what are we going to have? We're going to have 3/4, 6/8. You do it.
3/4.
Yeah, 3/4.
6/8.
Yep, keep going. Oh, jeez. Having difficulty today. So 6/8, etc. And do out 12 of them. So 3, 6, right? Then 9, what's that? That's 3 3s over 4 3s. 4 3s is 12, right?
9 out of 12.
9 12s, yep. And then what? What's the next one? 12.
12, 16.
How much?
12, 16.
12 16s, I like it. Okay. I thought you said something else. And then what?
And then it's 15.
Yep, 3 5s.
15.
Yeah.
15 20s.
I like it. 15 20ths. I like it. Keep going.
And then.
Because basically, really, that's what you're doing, right? You're doing 3 of them, right? Over 5 of them, except I don't have 5 of them, so I'm going to build it like this.
There, 12.
Bam. Bam. There it is.
6. Done.
Right? How far did you go?
6.
Keep going keep going all the way to 12, you. You're going to wind up with 30/40 at one point, and then you're going to wind up with, what's 3 12s?
3 12s is 36.
What's 4 12s?
48.
There you go. So 36/48, still just 3/4. Now, here's the next thing we can do, just for fun. But wait, finish that. Now we're going to do some division. A few problems in division. Get used to the decimal equivalents.
There, 30/40.
There you go. And then what? 33/44.
Yeah.
Okay. Alright, so now I'm going to give you some division problems. How many 2's are contained in 1? We're going to do decimals.
2.
How many 2's are contained in 1?
How many 1s are contained in 2, or how many 2s are contained in 1?
2 is contained in 1 how many times?
0.
Alright, you're correct. There's none of them in there. Now we got to put a decimal point in there. How many times is it contained in 10?
0.
Oh, wait a minute. How many 2's are in 10?
Oh, 5.
Done.
I thought you said how many 10s are in 1.
Alright, done. Right? Write it down, put it in your notebook. So now I know 1/2 is the same thing as 0.5.
Okay, so I'll do that right here.
Yeah. We've done division before. We can play with blocks, but basically what we're doing is we're saying, look, there's 5 2s in a 10. Which is basically just saying, look, there's this. And now I've made this into a 10th, right? This is actually now, I've just changed my mind. This is no longer 1. This is 1. So this is 1. How many of these are contained in there? How many 2s are contained in one of, well, 5 of them. And I can get them out.
It's right up my book.
Right? Bam. Alright, I like it. So we're just counting how many of these contained in there. Alright, how about the ones that we just did? We'll do... Actually, I want to know how many 3s are contained in 1. That's a fun one. How many 2s are contained in 3? Actually, let's not. Actually, let's do it the other way. Wrong. How many 3s are contained in 2, right? And then.
No 3s are contained in 1.
Excuse me?
No 3s are contained in 1.
You're correct. Now I have to figure out how many 3s are contained in 10.
3.
3 is the correct answer. Uh-oh. 1, 2, 3. But you know what's going to happen?
What?
There's going to be 1 left.
Yeah.
So what's going to happen? It's just going to be 3, and then 3, and then 3. It's never going to stop, right?
Yeah.
Alright, so here's what we're going to do. I'm going to put a line like this. I can do it 2 ways. There's multiple ways to do it. Usually it's this way. And I just put a line like that that says, oh, it repeats forever. Alright, try this one. How many 3s are contained in 2 10s? Because you're right, there's no 3s. There's not going to be any 3s there, right? So we're going to have a 0. How many, and you don't need the 0, by the way. You can just do this. Right? Don't need to write it. There used to be a big argument. Why do we need a symbol if it doesn't stand for anything? Alright, so how many 3s are contained in 2? Or 2 10s?
0.
Alright, 0. And then how many more? 3 times what is close to 20?
3 times what is 5.
3 times 5 is 15. I think we get another 3 out of that. Try again.
6.
6. Alright. So if I did 6, you're not writing these down, I can see it.
I am.
Okay. So if I do 6, I wind up with 18. Uh-oh, 1.8 actually, because it's 0.6. And now I've got a 2 again. I know what's going to happen. Oh, it's just going to be that over and over and over again, right?
There.
That's called a repeating decimal. And you'll get them with 6s and 3s and 9s. Alright, how many 4s are contained in 3?
None.
None. I like it. We'll put the 0 there. Alright, so how many 4s are contained in 30?
7.
7. I like it. What's 7 times 4?
7 times 4 equals 28.
Yeah. And it was 0.7, so it's 2.8. Alright, so then what's left? Oh, 2. How many 4s are contained in 20?
4s and 20.
Yeah.
5.
Done. So now I can see that 0.75 and 3/4 are the same thing. 0.66 and 2/3 are the same thing. Obviously 1/2 and 0.5 are the same thing. And 1/3 and 0.33 are the same thing. 2 different ways of naming the same number. One is a fraction, one is a decimal.
There.
Make sense?
Yes.
You want to figure out a couple more of them just for fun? So we did 1/2, we did 1/3, we did 2/3, we did 3/4. What's a couple other cool decimals? I'll tell you what, let's just do a few of them in a row. We'll do it the way they would do it like in public school. So here is 1/2, 1/3, 1/4, 1/5, 1/5, 1/6, 1/7. We'll do 1/8 all the way to 1/9. And I didn't fit it all on a page, but you can see it goes from 1, right? All right, so we already did the first one. That's 0.5. So let's see here. 1/2 is the same thing as 0.5. What's 1/3 the same as? Well, that was the same thing as 0.33 going on forever, right? And
Yeah.
what's 1/4 the same as?
1/4 is the same as.
What's a quarter? What's a quarter? 1/4.
What?
That's a quarter. What's 1/4 the same as?
25.
25. I like it. So let's just put 0.25. Do you believe me?
Yes.
Check it with your math. How many 4s are contained in 1? Well, 2 would give me 8, and then there'd be 2 left, and that'd be 5, right? 5 times 4 is 20. Ooh, he's doing the math. I like it.
There.
Alright, I like it. So let's do one more. How about 1/5? That's an easy one. What's that the same as?
1/5 is this.
How many 5s are going to be in 10?
5s and 10 are 2.
2. So that's going to be the same thing as 0.20. Right?
Yeah.
I'm going to put 0.50 over here just if I want to make everything copacetic. Alright, let's do 1/6. And then 1/7. And then 1/8. And then 1/9. You do them. It's your math lesson, not mine. Put your football down. Grab your pencil and paper. Who did you want for the Super Bowl?
Patriots.
No, you got the team that you wanted then because they won. That was so rigged, it was ridiculous. Yeah. But anyway.
Glad
everybody was happy. Well, except for the Los Angeles people. So what's 1/6? How many of them are in there? I gotta do how many 6s are contained in what? Well, like you keep saying, 0. And then I do 10, and I can see that there's at least one of them in there, right? Oops. And that'll give me 4. Uh-oh, now, how many 6s are in 4?
Putting everything down.
Okay. 6 is going to go for a while.
I'm putting everything down.
Alright, you're copying them all down? You can just do one at a time, but it's fine. But the idea is that you get a sense that 1/2 is the same as 0.5, 1/3 is the same as 0.33, a quarter is 0.25, a half is, or excuse me, a fifth is 0.20. Obviously there's 5 of them, right? 20 and 20 and 20 is going to make, right? Think of it like money. A fifth of a dollar is 20. A quarter of a dollar is 25.
Okay, now 1/6.
1/6, now you got to do the math. So far I got this far.
So that.
So then what? How many 6s in 4? None.
Yeah.
So you got to do 6 times what is close to 40?
6.
Would only give you 36. I like it, right? If you do 7, you get 42. So let's see, 0.16 gives me 40 gives me 36. Uh-oh. There's 4 again. So what's it going to be?
Oh, the line.
The line. Well, wait a minute. I'm going to put another one in there just for fun. And then I'm going to put the line. And you know what? You can put one. You can. This is also correct. Make no mistake. No one's going to give you a hard time for that. I hope. All right, sevens. Got fewest symbols possible. That's better.
Sevens.
Sevens. So now I'm going to change this to 7. Still just going to be 1. But now I'm going to have 3 left. So then what?
0 goes at the point before.
Wait, I got the 0, got the 1. Now what?
Behind the point, put 0.
Behind the point? What point?
The one where it's blank.
Where?
That one. That's
Here?
the 7.
Oh, I see. You want another 0 here is what you're trying to say?
Yeah.
Alright, fine. I like it. I'll take it. Keep going. How many 7s in 30? Oh, come on.
Okay, it's 4.
And then what? Now I've got 2 left. Put another 0, put another 0, put another 0, put another 0, put another 0.
There's so many zeros.
There's so many zeros. How many 7s in now how many 7s in 20?
How many 7s in 20?
That's what I asked.
Those.
Huh?
Those.
Dos. I like it. I like 7 because this goes on for days. I'm doing the math down here. You can't see it, but you guys follow along and do your own. So then what? What's 20 minus 14? Hurry up, you. Write it down.
6.
Yes. There'll be 6 left. How many 7s in 6?
0.
Alright, so how many 7s in 60?
9. No, 8.
Is going to give you what?
8.
8 is going to give you what? What's left when I take 7 times 8? What is that?
7 times. Oh, 2 is. Or 7 times 8 is 60. Oh, left is 63.
What are you doing? What's 60 minus 56? Focus, put your football down, sit down, grab your pencil, and do your math.
4.
Alright, it is 4. Now, how many 7s in 4? 0. So how many 7s in 40?
7 and 40 is 5.
I like it. Look at that. We're going to have every single number before we finally come back around, because it's just going to repeat. And what are we going to have? 35. So what's left? 5. How many 7s in 50?
57.
I like it, because 7 times 7 is 49. And look, we're back to 1. Right?
Oh my god. Like that?
So then you got to put the line all the way across. 142,857 is 1/7. Come on, tell me that's pretty cool. That's pretty cool. Let's see if I can fit it in there. Point.
Done.
All right, let's do 8. This one is not as bad. How many 8s in there?
0.
0. Alright, so I'm going to start off with my point. So, how many 8s in 10?
8 and 10, 1.
Alright, so there's going to be 1. That means there's 8. There's 2. How many 8s in 20?
2.
Which gives me 16. How many 8s in 40?
3.
What?
No, 4.
What?
No, 5.
8 times 5 is what?
40.
So it comes out quite nicely, doesn't it? 1.25. Or excuse me, 0.125. Didn't say it right. I had all the things in there with the wrong order. 1.25 and 0.125 are certainly two completely different things. Right? So there's 1 in there, and then there's 2 in there, and then there's 5 in there. Done. Alright, and then let's do 9. 1/9. What's that going to be?
1/9.
That's a fun one. That's super easy. What's going to happen every time?
What is it?
What's it going to be?
5. 1 and 9.
Wait a second. How many 9s in 1?
0.
0. Put the point. How many 9s in 10?
1.
And what's going to be left? Every time.
1.
So what am I going to have? It's just going to be 0.11, right?
Yeah.
Oh, and I forgot to put the line over here. Boot. Like that. There you go. Now let's just do for fun. Let's just see what happens. What if I had 2 9s? What's that going to be the same thing as? Sit down and do math. Take your pencil and do the math. Just give me the answer. And write neatly, you. So what are you going to get? 2 9s is the same thing as point what?
Point.
I love it. I can see him thinking. Chewing on the end of his pencil. Wait a minute. Yeah, no matter what, what's it going to be? See, he's 7. He's never seen this before. How many? Oh, come on, you. How many 9s in 2?
0.
All right. How many 9s in 20?
2.
Do the math, darn it. What's going to be left over?
2.
Is it ever not going to be 2?
No.
So what's your answer going to be? 2 9s is the same thing as what?
Um. 2.0.
Oh, really? Is it going to be 0? What's the next digit going to be?
Oh. 2.2.
And then what?
9.
You think it's going to be 229?
Yeah.
I beg to differ, and I have a serious problem with that. Sit down and do your math. How many 2s in 20? 10.
On 10?
Well, we have a serious problem though because we're counting by 9. So how many 9s in 20?
2.
So what's going to be left?
2.
Alright. How many 9s in 2? 20 again.
How many 9s in 2?
How many 9s in, well, 0. How many 9s in 20?
2.
And then what?
And then
How many 9s, what's going to be left?
2.
And then how many 9s in 20?
And 2.
Has anything changed?
No.
Alright, so then what's the next one going to be?
0.22222.
Forever and ever and ever, right? Because it's always going to be 2 left. It's always going to be 2 times 9 is 18. Minus, take it away from the 20, there's 2. 2 times 9 is 18. Take it away from the 20, there's 2.
Yeah.
Alright. Well, what happens if it's, say, 3 9s?
3 9s?
Yep.
Three 9s.
Chain division is no, this is basically no fun, but must be done. But he'll get it in a second, I'm sure of it.
Three 9s.
So what are you doing?
Putting that.
I see what you're doing. So what's 3 times 9?
3 times 9 is 27.
Take it away from the 30, what are you going to have left?
3.
Is it ever not going to be 3?
No.
So what's the answer? 3 9ths is the same.
0.33.
There you
0.
go.
As many 3s as you can put.
There you go. And isn't 3 9ths the same thing as 1/3?
Yeah.
Well, then why are we doing any work at all? Why didn't you just put down 0.333333? All right, let's try another one. What if I got crazy over here? What if I said 7 9ths? What do you think that's going to be?
7. Excuse me. Oh, I know what it is gonna be.
What's it going to be?
Wait. First, I have to do 7 times 9.
Yes, you do. And what are you going to get? 7 times 9 is? And then you take 63 away from 70, and what are you going to get?
7.
So what are you going to get every time?
0.777.
There you go. Well, let's say it right, though. It's not 0 point. It's 0.77, right? So what happens when you divide by 9?
What?
I said, what happens when you divide by 9? I believe we can make a rule here.
Oh, it's always the line, is it?
It's always the line there. All right, I like it. You're always going to get this line, that's for sure. And what's going to happen? If I have 7 9ths, what am I going to get?
6. As many 7s as you can put.
Okay, how about you just, that's why we don't do that, right? Mathematicians are lazy, we don't do that. So what if I had 5 9ths? What would that be?
5 times 9 is...
Oh, are you really going to do all of that? Can't you just say 0.555555?
Well, yeah.
Alright. What if I had 8 9ths?
0.88888888.
I like it. Alrighty. What do you think? You think we might be able to find some more of those? There might be more of those.
Yeah, I think there's more.
I think if you divide it by 3, you might be able to find something like that too.
Oh, yeah.
Well, I'm not sure though. You got to find out. I mean, you gotta, I'm just guessing. But with math, we can find out if I'm right or not.
Okay.
So we could do a couple like I think 5/3 would probably be repeating decimal. What do you think? It's going to be a mixed number. 5/3 is a whole, right? But let's just try it.
Oh yeah, it would be an infinite number.
It's a repeating decimal. Try and figure it out. What is it going to be? Well, let's see here. How many 3's are contained? Oh, wait a second. I don't think so, because wait a minute. There's a 1 in there. So do the math. Don't get lazy on me. Take your pencil and paper and knock this out. How many 3's are contained in 5?
1.
1. I like it. I can see that. And then I put my decimal in. So now I have 1 3 in there, and I'll have 20 left. How many 3's in 20?
I'm writing everything down first. And then 2. And then
what? Then I gotta take 3 times what is gonna be close to 20.
3 times what?
Yeah.
Is close to 20. 3 times 6.
Yeah, because I do 7, I got 21. That's 1 too many. And if I do 5, that's not enough. So it's got to be 6. All right. So then what? Then I'm gonna have 18. Oh look, it's gonna be 2 again.
Oh yeah.
So what I have here is basically 1 and 2/3, right? So there's 1 and 2/3.
Oh yeah, I see it.
Right? And this will be repeating forever. Alright, let's fool around. We figured out, let's see here, we got 1/3 is the same thing as 0.33. 2/3 was the same thing as 0.66, right?
Yeah.
Is this double that one, right? And 3/3 is, 3/3 is supposed to be 0.99, isn't it? But we know that 3/3 is 1. But if we were following this, and I can do 105 proofs on this, that 0.99 repeating is the same thing as 1.
Oh, yeah.
Interesting, isn't it?
Yeah.
It's just a little
Oh yeah,
fun.
0.33.
Right, because shouldn't 3 times this be 9999? But 3 times this is 1.
Oh yeah.
Alright, let's fool around with that was 6. How about, well I know that 2/6 is the same thing as 1/3. And I know that 3/6 is the same thing as 1/2. And I know that 4/6 is the same thing as 2/3, which is the same thing as, what do we figure out 2/3 was?
2/3 we figured was 3/4.
Oh, wait a minute. 3/4 is a whole other animal. That's this. What's 2/3?
Oh.
What's 2/3 as a decimal? Look on your paper. You should have it right in front of your nose someplace.
I do.
What is it? You said
Here
searching.
it is.
What's 2/3?
2/3 was that? 2/14. No, 2/3. Here it is.
Is the same thing as what? In decimal. I'm gonna make you do it again if you can't tell me. Alright, then write it out and do it again.
I read it out here.
Well, then what's the answer? What's 2/3? Alright, then let's do it again. What's 2/3? Write it out. 3 is contained in 2. How many times?
3. Oh, it's on this page. 3. Oh. Oh, here it is. 6. 3 is contained in 2 0 times.
Alright, I like it. What's the decimal? 2/3 is the same thing as what? What decimal?
0.6.
0 points, and is that it? Or does it repeat?
Yeah, repeats.
Alright, so then you can't just say 6. You can say 0.6 repeating. You can say 0.6 with a line over it. You can say 0.6666666 and people get the idea. But you can't just say 6, because that's not anywhere near a right answer.
0.6 with a line.
Alright. So let's see here. We figured out that we knew that what 1/6 was. We figured out what 2/6 was. We figured out what 3/6 was. We figured out what 4. Did we figure out what 4/6 was? Well, that was the same thing as 2/3, right?
Yeah.
What's 5/6? I don't think we did that.
We didn't.
All right, let's try it. What's 5/6?
I'm making my.
We're fooling around with thirds. We figured out that 9. If I did 9, that's just going to be 0.11. If that's going to be 0.22, that's going to be 0.33. That's going to be 0.444. That's going to be 0.5, right? But this is 6, so we figured out that this is. What did we figure that out? As a 1.666. We figured out that that's the same thing as 1/3, right? 2/6 is 1/3, so that's the same thing as this. 3/6, that's easy. That's the same thing as that. 4/6, right? So we're doing equivalent fractions here, kids. Right? And decimals thrown in for fun. 4/6 is the same thing as 2/3, right?
Yeah.
So 2/3 was 0.66666. What's 5/6? You got the pencil and paper, no calculator. Bust it out. Do it. How many 6's are contained in 5? And do you see now that, look, it's just division. These fractions it's just division, right? I'm just dividing this one into that one. How many of these are contained in that?
0.
You're correct. Keep going. Come on, this is kind of fun. Just seeing how the numbers fit together. Let's see if we can do the same thing with 8s. What's the same thing, right? This is easy. 2, and then we're going to do 2/3, and then we're going to do 1, 2, 3 of those, and then we're going to do 1, 2, 3 of those, and then we're going to do 1, 2, 3. I went to 6. Skipped over.
0.30.
Alright, so wait a second here. 0. Okay, so 6 in there. Wait a second. So that's 30. 6 times 5 is 30. Right? Well, that's nowhere near enough. I can get closer than that. What's close? 6 times what is close to, right? 5, 6. What's close to that?
What's close to what?
50. I want to know how many 6's are in 50.
Oh.
Like all of a sudden you can't do division? Come on, you.
Oh, okay. Um, 8.
I like it. Because 6 times 8 is 48. That's pretty darn close. Alright, but I have 2 left over, darn it. Now, how many 6's in 20?
Can I hear you?
How many 6's in 20?
4.
Try again.
No, 3.
Yeah, because 4 is 24, man. You went over. And what's going to happen?
There's still 2 left?
And is it ever not going to be 2 left?
No.
So 5, 6 is 0.833333, right?
Yeah.
Look at that. It's always, with this is 6, there's always going to be some kind of repeating thing going on there most of the time, right?
Yeah.
Not always, because like on this one it's just a half, and on this one it's, right? But, oh, and then 6, 6 is just a whole one.
My pencil's not working.
How's your pencil not working?
It just wasn't, like...
The lead is
drawn.
messed up. Alright. Okay. Alright, like I said, and this is like, you gotta do these. You have to. Because otherwise, you never, I mean, you gotta run into these numbers and play around with them and see how they work. Alright, what about, what did we just do? We did 6, 7, so I'm gonna skip over 7s for the time being, because you know what? 7s, it takes a lot of work. Let's do 8s. So I've got...
Can we do, like...
1/8, we figured out is 1.25. What's 2/8?
2/8.
Well, it's twice as much as that. What's that going to be?
2/8 is.
Well, can I reduce it? Is to what? What?
1/4.
1/4. So what is that the same as in decimals?
Half.
Half is definitely not the same thing as 2/8. 4/8 is a half. This is only 2/8.
Mm. Oh.
So what's 2/8 the same as a fraction?
2/8 is the same thing.
So you're going to be begging me for algebra next week. Oh, come on. What's 2/8 the same as? Just reduce it.
It reduces to 1/4.
It reduces to 1/4. What's 1/4 the same as? It's even written on the board in front of you.
25.
0.25. A quarter. Alright, what's 3/8?
That's what I thought from the start.
You certainly did not. What is 3/8? And can you see that, look, 1/8 is the same thing as, look, I just take point.
Oh, it's still 25. Oh, no, not 25.
Isn't that the same? 1.25 and 1.25 gives me a quarter, doesn't it? When I add them together?
Yeah.
So wouldn't this just be one more 1.25?
Yeah.
What would I have?
1.25.
Oh, please. I have 3 of them there. Add them together. Quit being lazy.
$3.75.
I like it. That's 3/8, right?
Yeah.
Alright, 4/8 is a half. That's pretty simple. Oops, why am I putting equal signs there? In fact, nothing goes there. 4/8. Maybe a dash. That's just a half, isn't it?
Yeah.
Alright, what's 5/8?
5/8.
And I'm going to be 6/8, and then 7/8, and then 8/8 is just 1. I'm breaking up my 8s. So let's see, so far we figured out what that is, which is 1.25.
Yeah.
Then we figured out that that was the same thing as a quarter. Then we figured out that that was the same thing as 3.75. Then we figured out that that was the same thing as a half. Now we're trying to figure out what that is. So now you have multiple ways of doing it. You can take 8 and divide it into 5. You can take 1.25 and multiply that 5 times. I don't care, but give me an answer. I want to know what 5/8 is as a decimal.
625.
0.625, is that what you're trying to say?
Yeah.
I like it. What is 6/8? Well, 6/8 is just...
0.650.
Oh, hold on a second. What's 6/8 the same as?
0.650.
Oh, try again. What's 6/8 the same as? Can I reduce this? I'll give you a hint.
Yeah.
Divide by 2, you baby monkey.
Oh, 3/4.
What's 3/4 the same as? Well, I know what 1/4 is. What's 3/4?
75.
70.75.
0.75.
Right? Okay, so 6/8 0.75. And we should have done the quarters. We didn't do the quarters, did we?
No.
All right. Then we should do these, right? Where I see, you got to get just number sense. We're fooling around with fractions. Here's 1/4. That's 0.25. Here's 2/4. What's that the same as?
0.50.
There you go. 0.50. A half. What's 3/4?
3/4 is 75.
0.75.
0.75.
There you go. All right, like it. Let's do fifths. What's 1/5? Well, 1/5 we figured out is 0.20. What's 2/5? And then
2/5.
3/5, and then 4/5, and then 5/5. What's 2/5 the same as? Oh, come on. How many 5s in 20? Or just multiply by 2.
4.
Give me the right answer.
0.4.
0.4. What's 3/5?
0.5.
Oh, come on. Does that even make sense? 2, 4, 5?
No. 248. 0.8.
Oh, you skipped one. Over here you're going to get 8.
Oh, 6. 0.6.
Isn't it?
Yeah.
I mean, we're just counting by 2s. If 1/5 is 0.2, then 2, 4, 6, 8, right?
Yeah.
Dude, you're trying to make this hard. Don't make it hard.
I was doing doubles.
Ah, I see. Oh, yeah. Well, okay, but see, okay, but if you doubled this, you got 4 over there, 4/5, not just 3. Make sense?
Oh. Yeah.
Yeah. Okay. All right. So then we did some sixths over here. Dude, you should be writing some of these down, not just watching. So you know what 1/2, 1/3, 1/4, 1/5, right? 2/4, 3/4, 1/5, 2/5, 3/5, etc. Right? Now we're just doing 6. We skipped over 7 just because 7 takes a long time to do the math of the 7s. And then we did the 8s. And then the 9s are super easy because it's just, 1, 1, 1, 1, 1, 1, right?
Yeah.
And we're just fooling around with numbers, playing with fractions, seeing what their equivalents are, seeing what their decimal equivalents are, figuring out that, hey, wait a minute. So this is the how many part, this is the what kind part. This is the numerator, this is the denominator. Fractions tell you a bunch of things. This can be a discrete number, 1/4. It can be a decimal relationship, that's 2 things. It can be a ratio, 1:4. That's 3 things. Right? Fractions can be all kind of different things, 4 different things. A discrete number, a ratio, a decimal. Right?
Yeah.
A division problem, which gives you a decimal.
Yeah.
So we like fractions because they have it tells you all kind of stuff, all in one number. And then fractions are pretty interesting when you put them together, because now once we start figuring these out, we can add them, we can subtract them, we can divide them. We can figure out how many quarters are contained in a fifth, if we wanted to. We could figure out, and then there's just a shortcut for doing that. That's just invert and multiply, right?
Can we do some algebra?
We can do some algebra next week, because guess what? Our hour's up. Can you believe it?
No.
Me either.
I'll be up in 6 minutes.
I know. I thought we were just getting started, but we're not. No, we started at. Actually, we've gone over when you get down to it.
Wait, seriously?
Yeah.
How much?
Yeah. Well, just a little bit, but I mean, I don't care. I don't have a class after this, so it's okay. And I like playing with you. But next week we will play. You don't need to get your mom. But next week we will play algebra. And we'll fool around some more with these numbers, and maybe we can do some ratios, and we'll do some more problem solving, and fool around fractions, just goof around. Okay? How'd you like class today? Today wasn't so much fun because we were just doing, fooling with numbers and division and stuff like that, and playing with paper and pencil. It's more fun when we play with blocks.
Yeah.
I agree.
Oh.
Yeah, but the idea is that you need to know what these numbers are. And you need to have an idea of the difference between, 1/5 and 1/4, or 1/8 and 1/5, right?
Yeah.
There's a big difference between those numbers. And
Oh, yeah.
what's close? Well, let's see here. Close to 1/5 and 1/8. Well, let's see, 2/8 and 1/5. That's kind of close, right? But
That is
2/8
close.
but 2/8 is actually 1/4, so it's not really that close, right?
Yeah. Not that close.
But the idea is that you want to have an idea of how these fractions work, and their equivalents, and what's bigger and what's smaller and so forth. And the only way to do it is to play with the numbers.
Yeah.
That's all it is, right? Some of it actually takes a little bit of work. And see, 1 hour like this in 20, literally, right? Because mostly we play with blocks. So next week we will play with fractions, and
Yes.
we will play with decimals, and we will also do algebra. But actually, I think we're going to start with algebra because that'll be the most fun, is to do the algebra. And then and we can start fooling around with this, and then we can start figuring out. Well, let's see here. What if I had something like this? If I had and see, this will go right into the trigonometry. Is let's say I had, I don't know. Let's do two.
Is class?
Yeah, class is basically over. This is bonus. 2/8 is the same thing. Actually, let's make this an x over here, and I'll make this the same thing as 0.25. Oh, how do I do that? How do I solve for x like that? Oh no. Alright, we'll figure that out next week. But I mean, this is where we're going. Can you tell me the answer? Just because of what we did now, without doing math?
17.
17 over 8 is not going to be 0.25. How'd you even come up with
Oh.
17?
2 over 8.
2 over 8, that's right, because 2 over 8 is the same thing as 1/4, and 1/4 is the same thing as 1/4.
Oh, yeah.
Right? But there's a way to do this where we can solve for x, but anyway, we'll come to it next week when we do some algebra. Alright, I think you did good. Did well. Had a fun time. A little less goofing around with your football, and I would be happy, but other than that, I think you did a great job, boy. So I will see you. Oh, and I will see you next Monday.
Yeah.
All right. Stay warm. Oh, what's the weather like? Crewton Ramone's House of Math.com for more.
20.